Hi, my name is Chu Yu Mei from Group 4, and others member is Do Jing Yi, Nuru Kairato Africa, and Chao Yi Xian. Today, we want to present the assignment of the digital system. The assignment is to introduce Verilog hardware description language, digital binary multiplier, and counter using FSN in Verilog. To start off part 1, we will cover the VHDL to discrete this component at the grade level using Verilog, and then simulate them within ISE. Next, the binary multiplication calculator by using hard adder and the full adder will be discussed. For part 2, we design a synchronous digital system that detects and recognizes student ID by using the counter. Now we go through part 1. To design a binary multiplier where A is multiplier bit and B is multiplicand bits. This question is 6 by 6 bit multiplier. So A equal to 6 and B equal to 6. 6 by 6 equal to 36 and get are required. Since the question requirements is to use 1 big full adder and hard adder, so we need 29 full adder and 6 hard adder. The output is 12 bit P0 until P11. This is the step to solve equation part 1. Next is the hard adder and full adder diagram. If we have two input AB, we use hard adder. When we have 3 input A, B, C in, we use full adder. Now, I will pass to Chao Yi Xian to present. Thank you.
Okay, thank you, Chu. Good morning to everyone and Professor. My name is Chao Yi Xian and I will continue presentation for part A. So as you can see from the coding, there is one output P and two input A and B. So 12-bit output P, and so P0 until P11, and both A and B input will have 6 bits. So A0 until A5, B0 until B5. So total of 84 wires will be used, has been used. So and then you can see as this example, AND gate for the line 2. So wire 1 will be the output and A1 and B0. So this one A1 and B0 output, and the output is what W1 will go to half adder, and then the W wire 2 is here, and A0 and B1 for the AND gate. So the half adder will have 2 input and 2 outputs. So the input is W1 and W2, and the outputs in W3 will go to full adder for the next. And then another output will go to P1 for the output. So we then continue the coding until it's finished, and then we will run the behavioral check. After it's checked, and then we will go to another coding. This is a half adder coding and full adder coding. After we're done, we will run the schematic diagram and the block diagram. So this is the block diagram for the multiplier 6-bit but times 6-bit. So you can see A has 6-bit and B has 6-bit, and the output P has 12 bits. So the schematic, this is a schematic after zoom up. You cannot see clearly, but I will put in the report later. And then for the test bench, this is the test bench. the test bench coding. So you can see both A and B input has 6 bits, output 12 bits. And this is the binary number as I set to calculate for the answer later in the output in the waveform. And the first one is 3 bit in decimal, and the second one is 5 bits in decimal. If number 5 value in decimal. So the answer should be 15. The second one is 55 times 61, so the answer should be 3355. So we will run the behavioral check. After it's checked, no error, and we'll run the simulate the output. So you can see after 200 nanoseconds, the coding will finish. As we add a dollar finish here to stop the program. You can see the answer for the first one is same. So for the first one is same, 00 and 1111. Stop at 100 nanosecond, and the second one stop at 200 nanosecond, and the output is same as we expected. So that is all for part A. We'll continue part B from Tu Junyi and Kairato. Thank you.
Thank you, Chow. So now I will present for the part B. I will show the coding with the software. Okay. For this coding, we will divide into the 3 parts, which is part 2 to declare the input and output. Then the second one is for the counter. Then for the test bench. So in this test bench, we will set our value pass and the pass in value. Pass in value is the value that we set for the correct password. Value pass is the password that we try to enter to detect is correct or not. So now I will run the simulate behavior module to get the timing diagram. Okay, this one is a timing diagram. So I will change the value pass and the passing value to the hexa to easy us to do the difference. Okay, so now in this timing diagram, you can see when the enter is 1 and the value pass is correct to the passing value, so the access will become 1. So it means that the password is correct. When the access is 1, it will continue for 3 nanoseconds from here, 1, 2, and 3, and the access will become 0 at here. So it's continue until the value pass is finished. So this one, for the second one, we test for the wrong value pass. We can see that it will become 1. Is count that when the value pass is different to the passing value. So here is 1, second, and this one is the third. When the third time, the count is become third time, so the alarm will become 1. The alarm will on until it detect the reset at here, so the alarm will become 0 back. Okay, now I will show the block diagram and the schematic diagram. So this one is the block diagram. Okay. So this one is the schematic diagram. So this one will be the full schematic diagram. So this is all from the part B. So I will pass my presentation to Kai. Okay, thank you.
Thank you to Junyi. I will explain about the discussion and conclusion. This assignment has been divided into the two parts, A and B. Design, simulate and verify has been successfully done by us. For the part A is required to design a 6-bit multiplier using 1-bit full address and half address, which means there will be a lot address in the schematic diagram. The total of 29 full address and 6 half address were used. For the half address and full address, it have a little different coding, which half address is more simple and for the full address is a bit complicated. For the 6-bit multiplier, the input has a 6-bit assigned under A and B, 5:0. So a total of 12 bits of output will be generated, 12:0. And for the simulation design, the result will be in the binary number. And for the part 2, it's a synchronous digital system that will detect student ID as a password. If entering the wrong value password, the alarm will on. It a function reset apply to the coding to turn off the alarm. Next. So the conclusion, the purpose of this lab was to learn about the Verilog module. Verilog describes a digital circuit or a system as a set of modules. Modules is to state the input and output ports, like the example from the coding part 1 and part 2, is state after the module is state the input A, input B and output for the design. After that, we learn about the multiplier, that is a digital combinational circuit used for multiplying two binary numbers, half address and full address. After that, we learn about the synchronous digital system, like a part 2, which means digital circuit in which the change in the state of memory elements are synchronized by a clock signal. Like the example part 2, that system that detect the student ID as a password and generate an output signal. I think that's all. Thank you.